Good afternoon, children. Today I am going to tell you methods for the preparation of aldehydes. As I have already told that this chapter is very much important, and these methods include three name reactions, and all of these are very much important. And I have already told you that we get one 5 mark question from the chapter of aldehydes. So let me begin with the first methods for the preparation of aldehydes. The first method for the preparation of aldehyde, which you have already studied in the chapter of alcohols also, is by oxidation of alcohols. By oxidation of alcohols. Oxidation of alcohol is done in the presence of a strong oxidizing agent like potassium dichromate, potassium permanganate. It may be chromium trioxide. The alcohols will be converted in the form of aldehydes. Let me take an example. RCH2OH. The reaction is taking place with nascent oxygen because the potassium dichromate or potassium permanganate, they are either taken alkaline or acidic. There is a formation of nascent oxygen and there will be conversion of alcohol in the form of aldehydes. So the same method is used for the preparation of ketones. The same oxidizing agents are used, but in this process the aldehydes are further converted in the form of carboxylic acid. So as soon as there will be formation of aldehyde, we have to distill it off. We have to separate it, otherwise these aldehydes will be converted in the form of carboxylic acid. Similarly, if we take secondary alcohol, the same oxidizing agent is used. It will be converted in the form of ketone. There will be the formation of ketone. You can write large number of examples for the oxidation of alcohols. I have taught this in the previous chapter where you have written so many reactions for the oxidation of alcohols to form aldehydes. The second method is the dehydrogenation using copper as a catalyst at 573 Kelvin. The second method for the preparation of aldehydes is by dehydrogenation of alcohols in the presence of copper as a catalyst at 573 Kelvin. Although I have already taught this reaction to you in the chapter of alcohols, but let us repeat this reaction. If there is any alcohol is present and the reaction is done with that of a copper at 573 Kelvin, primary alcohol will be converted in the form of aldehyde. The secondary alcohol will be converted in the form of ketone, and if there is a tertiary alcohol, it will be converted in the form of alkene. This has been already discussed. Let me take an example. Suppose there is a alcohol. As the name indicates, it is dehydrogenation. So there will be a removal of hydrogen. The reaction takes place in the presence of copper at 573 Kelvin, and there will be formation of aldehyde taking place. Similarly, if secondary alcohol is taken, in this case the copper is used as a catalyst at 573 Kelvin. In this case there will be formation of ketone taking place. So this was the second method. These two methods you have already studied in the chapter of alcohols. Now all the methods are new. The third method is the preparation from hydrocarbons. From hydrocarbons. There are two methods. The first one is by hydration of alkyne. By hydration of alkyne. Let me discuss this reaction with example. Suppose there is a ethyne. It is an alkyne. When the hydration takes place, you know the meaning of hydration, that the reaction will be taking place with water. So, the reaction will be taking place with water. Water will break up as H positive and OH negative. So, initially there will be formation of intermediate. Initially there will be formation of intermediate. This is enol form. The tautomerism will take place. It is unstable. This intermediate is unstable. So what will be happening? That one of the hydrogen from here, that will be shifted here. So there will be formation of aldehyde taking place. So the hydration of alkyne takes place in the presence of water. Initially there will be enol form. It is known by the name of vinyl alcohol, and after that there will be tautomerism. One of the hydrogen that will be shifted here, and there will be formation of aldehydes. Now suppose instead of ethyne there is a propyne. Instead of ethyne there is a propyne, and the same hydration reaction is taking place. In that case, again the reaction will be taking place with water, and there will be formation of unstable intermediate, which will be converted in the form of ketone. The reaction will be taking place like this. It will be C, there will be OH, double bond, and CH2. Now again there will be shifting of one of the hydrogen here. So there will be formation of ketone taking place in this case. So if there is ethyne, there will be formation of aldehyde. If there is a propyne, the formation of ketone taking place by this manner. Now the one more reaction which you have studied in class 11th also, the aldehydes can be prepared by ozonolysis of alkene. Ozonolysis of alkenes. There will be either formation of two aldehydic molecules or one aldehydic and one ketonic molecules. The reaction takes place in the presence of Zn. Let me take an example. Suppose there is a ethene. The reaction is taking place with ozone in the presence of Zn. So first there will be formation of a ozonide. First there will be formation of ozonide taking place. It will be cleaved like this. So there will be formation of two molecules of formaldehyde. I can write it like this, HCHO. There will be formation of two molecules of formaldehyde taking place in this case. The third oxygen that will go with zinc, that is the formation of ZNO, will be taking place. I can take more examples in this case too. Now, if the reaction is taking place with propene, that is CH3, CH, double bond, CH2, the ozonolysis is taking place in the presence of Zn. So there will be formation of again ozonide, CHO, CH2, O. So there will be formation of one molecule of ethanol and one molecule of methanol that will be formed in this case. So in this manner the aldehydes can be prepared by the ozonolysis reaction. Now, the next two reactions are very much important reaction. These are name reaction and these are favorite reaction of the board examiners. The first reaction is known by the name of Rosemond reaction. The first reaction is known by the name of Rosemond reaction. This reaction is the reaction of acid chloride with hydrogen. In this reaction, palladium is used as a catalyst. It is supported by barium sulfate. It takes place with the help of that, and sulfur or quinoline is added just to prevent the poisoning of reaction. Quinoline, these are added just to prevent the poisoning of reaction. We can prepare aliphatic aldehyde, we can prepare aromatic aldehyde. There will be formation of, in this case, aldehyde with the release of HCl. There will be formation of aldehyde with the release of HCl. In this case will be taking place. Similarly, I can take an example. Suppose it is C6H5 COCl and the reaction is taking place with hydrogen under the same condition. There will be formation of benzaldehyde. In this case, there will be formation of benzaldehyde taking place. So this is known by the name of Rosemond reaction. It is very important reaction from the examination point of view. The next I come to the preparation of aldehydes by using nitriles. By using nitriles. You know that in organic chemistry, the nitriles are used by the name of cyanides. In organic chemistry, the cyanides are known by the name of nitrile. Again, it is a name reaction. This is known by the name of Stephan reaction. The reaction of nitrile, this takes place in the presence of SnCl2 and HCl. SnCl2 act as a reducing agent. There will be formation of nascent hydrogen taking place by the reaction of SN2 with HCl. This nascent hydrogen will react with nitrile and it will be followed by hydrolysis. There will be formation of RCN, nascent hydrogen, by the reaction of SnCl2 with HCl. There will be formation of imine RCH double bond NH. When the hydrolysis takes place in the presence of acid, there will be formation of aldehyde with the release of ammonia. There will be formation of aldehyde with the release of ammonia. So in this manner the reaction takes place. This is known by the name of aldoimine. This is known by the name of aldoimine, and this imine will be converted in the form of aldehyde and there will be the formation of ammonia. We can do reactions with that of a alkyl nitrile, or we can do reaction with that of a aromatic nitrile, but the ketones cannot be prepared by using this method. The ketones cannot be prepared by using this method. There is one more method for the nitriles can be directly converted in the form of aldehydes by using a reagent which is known by the name of dibal. It is diisobutyl aluminium hydride. It is a isobutyl isobutyl aluminium hydride. CH3 whole twice CH CH CH2 CH3 whole twice. So it is its formula. If there is any nitrile and the reaction is done with diol, it will be directly converted in the form of aldehyde. Similarly, even if there is a presence of double bond, like we are having compound like this, CH, CH, CH2, CHO, only this compound will be converted, CN, only this compound will be converted in the form of CHO. This is CH3, CH, double bond CH, CH2, CHO. Even esters that can be converted in the form of aldehyde by using this method. Suppose there is a ester CH3, CH2 9, COO, O, C2H5, and the reaction is done with diol. This complete part that will be converted, rather than this complete part that will be converted in the form of aldehyde, there will be formation of CH3, CH2 9 and that of a CHO directly. So esters can also be converted in the form of aldehyde by using diol. Now I will tell you few methods for the preparation of aromatic aldehydes, and all these methods are only by using methyl benzene. All these methods, you know what is methyl benzene? That is toluene. All these methods can be prepared only, we can prepare aldehyde by using methyl benzene. So let me discuss first method. The first method is by using chromium chloride. It is the reaction of toluene with CrO2 Cl2. The reaction of chromium with chromyl chloride CrO2 Cl2. So this will be reaction taking place either in the presence of CS2 or in the presence of CCl4. Initially there will be formation of intermediate CH, O, CrO, H, Cl whole twice, and later on in the presence of water the hydrolysis will be taking place and it will be converted in the form of benzaldehyde. It will be converted in the form of benzaldehyde. The second reaction is by using chromium trioxide in the presence of acetic anhydride, that is CH3, CO whole twice O. If the reaction of toluene takes place in the presence of chromium trioxide and acetic anhydride, so there will be formation of a special compound initially which is known by the name of benzylene diacetate. That will be an unstable compound. So there will be formation of CH, O, CO, CH3, which after hydrolysis will be converted in the form of benzaldehyde. It will be converted in the form of benzaldehyde. The next method is by the side chain chlorination of toluene. The next method is by the side chain chlorination of chlorine. Now, if there is a toluene, the reaction is taking place with chlorine in the presence of sunlight, there will be formation of benzyl chloride. and after that hydrolysis it will be converted in the form of benzaldehyde. So this is by the side chain chlorination reaction जो है. The last method for the preparation of aldehydes is again a name reaction. This is known by the name of Getterman-Koch reaction. This is known by the name of Getterman-Koch reaction. In this, the reaction of benzene is done in the presence of CO and HCl. There is a formation of compound HCOCl which is converted in the form of benzaldehyde. So benzene, the reaction with CO, HCl, so it will be directly converted in the form of benzaldehyde. So all these are very important methods. You go through all these methods and do them thoroughly. If there is any query, let me know, so that if there is any indirect question, you are able to do that indirect question yourself.